Alright, welcome to this video on lesson 7.4, which is about special right triangles. So, in the lesson that we had last class, we talked about special right triangles. There are two types of special right triangles, both of which you explored in class. So the first exploration that you did was you were given an isosceles right triangle. So that's the first special right triangle. So in an isosceles right triangle, it's obviously a right triangle, but more importantly, my two legs are going to be congruent. So it doesn't matter what size the lengths of the legs are, they will always be congruent. Now, the first part of the investigation, you had to say what these angles were. Well, if you know that it's 90 degrees because it's a right angle, we know we have 180 is all three angles added together. So since two of my angles are the same, I can use that fact. So I know 180 is going to equal 90 degrees for my right angle, plus 2 of the same angle, which is that question mark. So I subtract 90 from both sides, and I get 90 degrees is equal to 2 times whatever that one angle is. So if I want to find what one of those angles is, I would just divide by 2. So I get 45 degrees equals one of those question marks. Since they're both the same question mark, that means I'm dealing with 45 degrees. So instead of 45 degrees, or instead of the question mark, we can put 45 degrees here. So each of these angles are 45 degrees. Okay? So that's why it's called a 45, 45, 90 right triangle, is because those are the measures of the angles. So next, we looked at, in the investigation, the relationship of the sides. So if we take this right triangle again, I'm going to copy it. Okay, so here's our right triangle. If they have the same side length, I want to find if there's any special relationship. Since they have the same side, if I use x, so this is any letter, any number rather, it doesn't matter what number I choose. It could be 1, it could be 2, it could be 100, it could be 500, it could be 1,375,000. Each of those legs will be the same. Now the question is, if my legs are the same, what's the hypotenuse going to be? So here's where we developed a specific situation. I believe in the investigation, the first example was 3 and 3 here. So they said, using the Pythagorean theorem, what is the hypotenuse going to equal? So if you use the Pythagorean theorem, you remember the Pythagorean theorem is leg 1 squared, which is 3, plus leg 2 squared, which is also 3, equal to the hypotenuse squared. I think they might have used x in the example, but it doesn't matter. Which letter we use, it's the same concept. So 3 squared is 9, so I've got 9 plus 9 here, equal to y squared. 9 plus 9 is 18, so that means y squared is 18. Well, I don't want y squared, I want y. Now, if you remember back from Algebra 1, to undo a square, you have to square root it. So I'm going to square root both sides of my equation. The square root of y squared is just y. So I'm left with the square root of 18. Now, in the exploration, you were supposed to rewrite this in simplest radical form. Now, what that means is you need to factor this out. What two numbers multiply give you 18? Well, when you want to factor it out, since you have a square root, you want to find a perfect square, the highest perfect square that goes into 18. Well, that gives me 9 times 2. 9 and 2 give me 18, and 9 is a perfect square. So really, this is going to be square root of 9 times the square root of 2 equal to y. What's the square root of 9? That's right. If you said 3. So this is going to give me 3 times the square root of 2. Can I take the square root of 2 perfectly? No. So I'm just going to leave it as the square root of 2. So you get y is the same as 3 square roots of 2. So I'm going to replace that. Okay. Now, if you did the next problem, I'm not going to do it for you, but if you did the next problem, you'd see that you'd have the same pattern going on here. You'll notice that I have a 3 here, those are the same, and then I have a 3 in front of my square root of 2. If you did the second part of this part of the exploration, you'll notice you'll have the same pattern. Whatever your legs are equal to, you will also have in front of the square root of 2 for your hypotenuse. So this is where we have our pattern. If I say x is my leg length, if I did x squared plus x squared, that's equal to my hypotenuse squared. So if I want to find my hypotenuse, I just combine like terms. So I'd have 2x squareds here equal to my hypotenuse squared. Since I'm just looking for the hypotenuse, not the hypotenuse squared, I'm going to have to square root it, just like we did last time in the specific example. And that gives me the hypotenuse equal to the square root of 2 times the square root of x squared. Well, the square root of 2 I can't do anything with, so I'm going to leave it as a square root of 2. But I can take the square root of x squared. Remember, also, the shortcut of a square root is if I square root a square, that cancels it out. So all I'm left with is x out front, which is what we wanted, because that means I'm going to have x square root of 2 for the length of my hypotenuse, which you'll notice again I have x, x, and x square root of 2. So that's the pattern here. X to x to x square root of 2. That's the ratio that any isosceles right triangle will follow. Any 45, 45, 90 right triangle will always use this pattern. Okay, so the next part of this exploration, it started out with you having an equilateral triangle. I'm going to try my best to make this as equilateral as possible. So in your equilateral triangle, you have to remember that you first had to find all three angles. First, we found that these were all 60 degrees. Okay? Now, if I were to drop the altitude from the top of the triangle down, that makes a 90-degree angle. Okay? And it also bisects the top 60-degree angle, which means I get 30 degrees. Now you should have written this down in the exploration part. Okay? We also know, since this is equilateral, that all three of my sides are the same. Since my altitude bisected the angle, what do you think it's going to do to the side it touches? That's right, it's also going to bisect this side. So those two parts are the same. So the first example gave you this was 8, this was x, this was y. Okay? Since the whole thing is 8, if I were to draw the altitude down to it would also get cut in half. So that means if all side lengths are 8, they would all get cut in half to equal 4, which means my x would have to equal 4, but so would my y. So in that first example, you'd have x equal to 4 and y equal to 4. The next example that they gave you for the exploration, I'm just going to erase the parts that aren't there. They tell you that this is 7, so what's x? Well, since 7 is my whole length, all I have to do is cut it in half to find my x. So x is going to equal 7 divided by 2. That could be your answer, or you can just say 3.5. Okay? Now, we found the relationship, or we should see a pattern in the relationship between the smallest side and the hypotenuse. That's just it's just half of it, right? The smallest side is opposite 30, and the biggest side is opposite 90. The biggest side is your hypotenuse. The smallest side will always be half your hypotenuse. Or you can say your bigger side, your hypotenuse, will always be twice the size of your smallest side. And I'll explain this a little bit more. So the next part you should have had to find out was, I think they gave you a 30, 60, 90 right triangle. And they told you, man, I just can't draw tonight. There we go. So if they give you a 30, 60, 90 right triangle, you had to find the side lengths. I don't remember exactly what the measurements were, but let's say we go with our 8 and our 4. How would you find the height of this triangle, the third side? Well, since we don't know the ratio of the sides yet, we're just going to use the Pythagorean theorem. So I'm going to do 4 squared plus, let's say this is x. That's going to equal 8 squared. 4 squared is 16 plus x squared equals 64. So I'm going to subtract 16 from both sides. So this leaves me with x squared equal to, let's see, that'd be 48. Is that correct? 64, 16. Yep, 48. So that works out. So that means now that I have my x squared, I need to get x by itself. So I'm going to square root it on both sides. So that leaves me with x equal to the square root of 48. But I need to factor out as much as I can. So I want to think of the biggest perfect square. So I have 4, 9, 16, 25, 36, 49. 49 is too big, so 36 on down. Will any of those go into 48? I know 4 goes into 48. That's 12. And 12 is 4 times 3. So really, 16 goes in, because 4 times 4 is 16. So I'm going to rewrite this as 16 times 3. So that means my x is equal to the square root of 16 times the square root of 3. What's the square root of 16? That's right, it's 4. So this is going to be 4 times the square root of 3. Can I take the square root of 3 perfectly? No. Good job. So that means this is my value for my x. Notice any patterns here. You should notice that we have a 4 here, a 4 here, and an 8 here. But this 8 is really 2 times 4. So I really have a 4 in each one. So if I replace 4 with x, that's your pattern. Okay? So your pattern, your ratio is going to be x to x square root of 3 to 2x. So that's the ratio you should have explored. Okay, so let's basically flesh this out a little bit more. And actually, I've kind of pretty much done the theorems for you guys already. So there's really not too much more information that we need to discuss. I'll just write it formally. So for a 45, 45, 90 triangle, right triangle, the theorem states the ratio of the sides are going to be x to x to x square root of 2. Okay? And for a 30, 60, 90 triangle, the ratio of the sides are going to be x square root of 3 2x. Okay? So this is the ratio for both the 45, 45, 90 and the 30, 60, 90 triangle. Remember, the first value is always the smallest in the 30, 60, 90. The second is the middle, and the third is the hypotenuse. Okay? So if I had a right triangle here, a 30, 60, 90 right triangle, this would be 30, this would be my x, 60 here, this is x square root of 3, and 2x on my hypotenuse. Okay, and a 45, 45, 90, you'd have x square root of 2. So to help you remember when you do square root of 2 and square root of 3, in 45, 45, 90, you have 2 of the same side length. So that's why you do x square root of 2. So we have 1, 2, the same side, so I do x square root of 2. Okay? That's how you remember it's 45, 45, 90. Then you just have to remember that the other one is a 30, 60, 90 for square root of 3. Okay? So there's really not too much more additional information that we need for this section. So let's go on to a couple examples. I'll try and get in a couple for each type of triangle. Actually, I'll do 2 for 30, 60, 90 since those are the more complicated ones. So let's say I have the following 30, 60, 90 triangle. Okay. So I have a triangle ABC. Here's my 30 degrees. AB is 8. I need to find x. So there's two ways you can do this. Well, actually, there's only one way you can do this. You're going to use the ratio. Since my AB is 8, I know the side opposite 30 is going to be half of that. So 8 divided by 2, that's 4. So that means AC is 4. So that means my ratio would be 4 to 4 square root of 3 to 8, or 2 times 4. So the only one that I haven't found yet is 4 square root of 3. So that means x is 4 square root of 3. Another way you can think about it is matching up the ratio. So I have 4, x, and 8. 2x is 8, x is 4. So whatever goes here, or since x is 4, I should say, this 4 would go here in my x. So I would replace that with 4, which means my actual x value that I'm looking for is 4 square root of 3. Okay? Let's look at another example. Okay, so here's my right triangle. It's 60 degrees here, and I have 6 as my length here. I need to find the two other side lengths for this triangle. Since 60 is opposite 6, that means I'm going to use, still going to use the ratio. Remember, the side opposite the 30 degrees, which would be the other angle, is your smallest, so this is going to be x. And this side length, my hypotenuse, is 2x. Which means that 6 is going to be the same as x squared root of 3. So I'm going to say 6 is the same as x square root of 3. Now I need to solve for x. That will tell me what my smallest side is, and I can use that to find my hypotenuse. So dividing both sides by square root of 3 is what I want to do because I'm multiplying x by square root of 3. So this reduces the square root of 3. So all I'm left with is x equals 6 divided by the square root of 3. Now if you remember from Algebra 1, we're not allowed to have a square root in the denominator. So I need to get rid of that square root by multiplying it by itself. So I multiply this by square root of 3. Now if I do something to the bottom of a fraction, I have to do it to the top, because that keeps it the same number. It's the same as multiplying by 1 over 1. So square root of 3 times itself on the bottom is going to be square root of 3 times the square root of 3, which we know is the square root of 9. Okay? And on top, I'm left with 6 square roots of 3. Now, what's the square root of 9? That's right, it's 3. So this is going to equal 6 square roots of 3 divided by 3. Doesn't look like we can see that over the series symbol. It's a little better. So now I can reduce anything else that's outside the square root. You can't reduce the 3's that you have in this. You have to have a square root for both in order to reduce. So that's when we reduce the 6 and the 3. So 3 goes into 6 2 times. So this gives me 2 square roots of 3. So my x value over here on the left is 2 square roots of 3. To find my hypotenuse, all I have to do is substitute this in here, which basically means I multiply it by 2. So the hypotenuse is going to be 2 times 2 square roots of 3. Now again, I can't multiply things that don't have a square root, both have a square root. So I'm only going to multiply the things that don't have a square root. So this is 2 times 2, which is 4. So my hypotenuse is going to equal 4 square roots of 3. So those are your two answers, 2 square root of 3 and 4 square root of 3. That's 30, 60, 90 triangle. Now, let's talk about 45, 45, 90. Okay, so here's our 45, 45, 90 triangle. And I'm only going to do one example for the sake of time and because these are a little bit more simpler. There's really only one thing you have to worry about for them. And that's when you involve square roots in the answers or in the problem itself. So if I have a 45, 45, 90, I know this is 45 degrees. That looks like 46 degrees. There we go. And I have 45 degrees here. Now, let's say my side lengths of my legs are 3 square root of 2. Remember, it's an isosceles right triangle, so they're going to be the same. So my question is what's the length of the hypotenuse? Well, if you remember, you can do this one two ways, actually. Method 1, you use the ratio. And if you remember, the ratio is x to x to x square root of 2. Since my x's are 3 square root of 2, all I have to do is match that up. So that means x is 3 square root of 2. So I'm going to take 3 square root of 2 and substitute it in here. Basically, I'm multiplying it by square root of 2. So I have 3 square root of 2 times the square root of 2. And again, I can only multiply things that have a square root over it together. So this is really going to be 3 times the square root of 4. Or square root of 2 times the square root of 2. So I have 3 times the square root of 4. But we all know what the square root of 4 is, right? That's 2. So this is 3 times 2, which is 6. So my hypotenuse length is 6. That's method 1. Method 2, is using the Pythagorean theorem. Okay? Since we know the two legs, all I have to do is square them, add them together, and that gives me my hypotenuse squared. So then I would just square root both sides and get my answer. So let's do that now. So I have 3 square root of 2 squared, and you'll notice I'm putting parentheses around this because I want to multiply the whole thing by itself, not just the 3 and not just the square root of 2. I want to multiply everything inside, square it by itself. So actually I'm going to move some stuff around here so I have more room. Okay, so when I square, I have to square everything. So 3 squared is 9. And square root of 2 squared, the square and the square root cancel each other out. So this is 9 times 2. Plus another 9 times 2 equal to your hypotenuse squared. So 9 times 2 is 18, so this gives me 18 plus 18 equal to my hypotenuse squared. Okay, let's move up a bit. 18 plus 18 is 36 equal to my hypotenuse squared. Now I just want my hypotenuse, I don't want it squared. So to get just the hypotenuse, I square root both sides. This gives me the length of my hypotenuse equal to, what's the square root of 36? That's right, it's 6. So that means my hypotenuse is 6, which is good because we had that from before. So the length of my hypotenuse here is 6. So that's kind of an example problem on how you can do a 45, 45, 90, and a couple problems on how you could do different ways of doing a 30, 60, 90. Alright, so here's going to be your multiple choice question. Pause the video here, answer that question, and here's your free response question. Hope you have a good night. Pause the video and enjoy. Send me some questions with your responses. Bye.